to deal with this differential equation, so they are telling us to find the general solution of the equation, the differential equation x squared dy by dx is equal to 3x squared plus xy. Now if you look at it clearly here, the only method that you have to use is homogeneous, because one, you cannot quickly separate variables, and you cannot quickly use linear exact here. So we go for homogeneous. So homogeneous tells us that we begin by dividing through with x with the highest power, in the equation. For example, by rewriting it, so we have x squared dy by dx is equal to 3x squared plus xy. So we begin by dividing throughout by x with the highest power. Why x with the highest power? We are going to see it. So divide through by x squared by x squared by x squared. So we end up having dy by dx is equal to 3 plus y out of x. Now we divide through by x with the highest power, because we know from homogeneous tells us that from y is equal to ux. Some people use v, others use, but it's a line whose gradient is whose y-intercept is 0. So a simple straight line. Now from here we have u as y out of x. So you always want to create a nature of y out of x, always. That's why we always look at dividing throughout by x with the highest power. So that's how you defeat it. If you divide through by x with the highest power and you get something like this, just know, or its formula, it can be square. So just know that that is homogeneous. So therefore, after reaching here, we even go ahead and differentiate this. We differentiate y is equal to ux. So differentiating y is equal to ux, you have dy by dx equal to u into 1 plus x du dx. I will use product rule, so for that case, so this gives us our dy by dx equaling to u plus x du dx. Now we differentiate this such that we can get something of this form. We can get dy by dx, and then we substitute accordingly. So substituting this equation 1 into this differential equation of ours, we shall have u plus x du dx is equal to 3. Now this is replaced with u, so we have u. So taking this side, we shall have x du dx is equal to 3 plus u minus u. Now here you see that these are going to cancel. So we have x du dx is equal to 3. Now after reaching here, you can clearly see now, whenever you reduce a homogeneous, it goes back to separation of variables. So here we can separate variables by saying, dividing both sides. So we can have x du is equal to 3 dx. So we can divide through by x, divide through by x. So we have du is equal to 3 out of x dx. Now after having this, we can go ahead and integrate. So integrating on both sides, so we can have u is equal to 3 ln of x plus a c. That c can also be line k. Yeah, that c can be line k also. But our u is y out of x, which is equal to now 3 line x plus line k. Now this 3 can go up, it can go up, so we can have y out of x is equal to line x power 3 plus line k. But line obeys laws of logarithm, so we can have it as y out of x equal to line k x power 3. Yeah. Now therefore, we can go ahead and say that truly our y, which is the function, is the same as x line of k x power 3. Yeah, as simple as this, you have defeated it. So our major aim always is to get the y, the function, where it came from. So this differential equation came from this. As simple as that. Don't forget to subscribe, please. Please subscribe if you haven't subscribed. Turn on the bell icon such that you receive a notification when I upload a new video. And then share. Yeah, when you share, sharing is caring. And then like the video. Comment where you have issues. Comment. Sharing is caring. Thank you so much. We meet in the next.